All right, this video is going to be a third one in sort of a set of three videos. This one's actually sort of going to show you how to go backwards and what kind of the trickiness of going backwards when graphing a sine or a cosine function is. Or I guess the trickiness, how do you write the equation of an already graphed sine or cosine? So the first thing we want to realize is, again, normally we write a sine or a cosine curve. So notice this time we want a cosine according to the directions. We're going to identify four major parts. Remember, we always take some number, we call it d, plus a leading coefficient multiplied by our cosine. Then we have a b value of some sort of multiple or factor inside of our cosine, multiplied by x minus c. Again, c being our shift left or right, just like d is the shift up or down. Well, if we can identify those four parts, we can write our function. So again, we're going to say a equals, b equals, c equals, and d equals. If I can identify those four things, we're going to be in great shape. Well, let's start with A. A deals with the amplitude, as we kind of have known in the past. So again, to deal with the amplitude, we need to know what's the distance from the middle to the top or the middle to the bottom, or if we really look at it, knowing that we're up here at 5 units high, and we're extending ourselves down to -1 units down here, we know that the total height of our graph equals 6 right now. Well, remember that the amplitude, right, is half that total height. So half of 6 would be 3, or basically from the middle to the top, middle to the bottom, that would have been 3 units. So for us, A equals 3. Now, we could also call that -3 technically, because remember, if we wanted to start at a minimum with our cosine, we're going to have to sort of pick a starting point. So I'll talk more about that here in just a minute when we talk about the c value. But for now, let's just remember the amplitude is definitely going to be 3 units. Now, what that also tells us is that to go 3 units, well, 3 units down from 5 would be at +2. And 3 units up from -1 would have been at +2. Or basically y equals 2 is our equilibrium, right? That's sort of our middle line. Well, remember that that's also where we get that sort of that d value, right? What's added on the outside. So again, up at +2 is going to be equilibrium, right? It's the middle. Vertically, that's the middle of our periodic function. Well, we've got 2 out of the 4 things identified. So let's move on. First, let's head back to that b value multiplied inside. Now remember, normally the period equals 2 pi divided by b. Doing some quick little algebra, multiplying b over to the left side and dividing the period back to the right. Basically, if we can identify the period, 2 pi divided by the period is also equal to b. Well, the period of our graph is going to be from either maximum to maximum. So that would be one way to look at this, or minimum to minimum. Or since we know both a maximum right now and we know a minimum, right? We know that at 3 pi over 2 we're at a maximum, at 7 pi over 2 we're at a minimum. Well, 7 pi over 2 minus 3 pi over 2 is going to be 4 pi over 2, or basically 2 pi. But now remember, that's only max to min. That's high to low. That's only half the period. So by doubling that, right, times 2, we're going to figure out very quickly that the period, right, equals 4 pi. Well, again, b value equals 2 pi divided by the period, or 4 pi. So we want a b value of 1/2 right now. After that, we just need to decide where we want to start from. Remember, c is the phase shift. Now, a cosine typically starts at a maximum, so to make our lives easy, why don't we pick this maximum point we were given? So our c value is going to be 3 pi over 2. And again, that remains, if we're going to start at a maximum, that's going to keep that a value as a positive number. So now we can go back and write our equation, y equals d being 2 plus 3, right, the a value, the cosine of b, or 1/2, of x minus the c value, 3 pi over 2. And that would be one possible, right, equation for our function. Now realize, again, we can change those ideas if we wanted to. Some of those things can change, some of those things cannot. Again, the equilibrium is definitely in the middle. That means that d is definitely 2 at all times. Again, this has to be a cosine, and we have to say 1/2 because the period's not going to change depending on where we sort of picture our starting points. However, if we wanted to, let's say we started at this minimum instead. Well, that means that our c value would change to 7 pi over 2, right? And in that case, we're starting at a minimum. That means that the a value needs to be negative, even though it's still going to be 3 units, right? The amplitude is still 3. But again, that would also be a perfectly good equation of our graph. It depends on if we start at the max or the min. And again, you could have also started at a different minimum point or a different maximum point. Again, if the c value changes, you want to be a little bit careful with the a value. The measurements are still the same. It's just all about where you started. Well, let's take a look. You might recognize those numbers. Pretty much the exact same graph, only this time notice we want a sine equation. So again, let's remember our major parts here. The equilibrium is still going to be at y equals 2, which again, thinking about a, b, c, and d, means that that last one is going to be 2. We're going to start up at, again, a maximum or down here at a minimum. Again, we're going to go from the equilibrium up or down is exactly 3 units. So again, that's our a value. B value, again, from minimum to minimum, or max to min and double it. Either way, again, we're going to have the same period that we had last time. So again, 7 pi over 2 minus 3 pi over 2 was 4 pi over 2, which was 2 pi. Double that is a grand total of 4 pi. And b, again, is 2 pi divided by the period. So again, still going to be 1/2. Now, the major idea, the big thing that's going to change for a sine curve, remember we want to start right on the equilibrium. So if we're going to go right on equilibrium, you'll notice, well, again, halfway in between, it's wherever we would have been at that y equals 2 value. And probably the easiest equilibrium value to spot is this one right here. Again, 3 pi over 2 to 7 pi over 2 is max to min. That's full 4 pi over 2. Well, half of that would have been 2 pi over 2. Or basically, if we add 2 to 3, or subtract 2 from 7, 5 pi over 2 is halfway in between 7 pi over 2 and 3 pi over 2. Again, that coordinate point there. I'm going to go ahead and use that as my c value. Again, if you want to find a different point on equilibrium, you absolutely can do that. The other thing I want to realize is that point, immediately following that, we're going downwards on our sine curve, right? We're headed down toward a minimum, which means I'm starting, right, with a negative a value. And very simply, I would just say d plus a minus 3, the sine of b times x minus c, 5 pi over 2 right now. Again, if you pick a different starting value, that might adjust your a value, or at least the a sign, right, plus or minus. But again, that c value could easily affect that. Again, if you have any questions about that example or any other examples, make sure you talk to your teacher. Otherwise, have a great day.